don't start, right? So that my notes are of some use that I've prepared by staying up till 6 a.m. today. So, very quick introduction. Some of you are meeting first time. I'm Zorawar Purohit. Primarily, I'm an entrepreneur, scuba diving instructor in the Andaman Islands, and I've started some businesses. I have a resort, a cafe. Self-taught developer, got into technology just to take care of my own small business tech. But then the bug bit me, and I'm on this lovely journey. Pi Delhi, Anuvrat, Animesh, Shubham, Ishan, Satya sir, and a lot of people have been these points of interaction and inspiration. And similarly, I arrived at a conversation about 6 months back, which had the word Elixir. And I thought it was a very cool word. I had no other idea except this notion that the word Elixir is cool. So in 6 months, this is the journey that I have been able to traverse in my comprehension of what this language has and what its potential could be. And that is what I'm here to share with you today, right? So we would like to start with Erlang's origin, and then we will finish with modern application, and we'll also do some code analysis in between of what their syntax is, what atoms are, and what makes it a little bit special in terms of beam, right? Which is the heart of all this, the Erlang VM. So before we start, there are a few words that are synonymous, I feel, with Elixir. That is extreme reliability, fault tolerance, a minimalistic Ruby-like inspired syntax, and the fact that it is compiled to bytecode, right? These are things we want to keep in mind, and you'll see how it unfolds in the next few slides. And do appreciate the animations, it took a lot of time. So what we'll be covering is history of Erlang, birth of Elixir, recognized contributors and organization, Elixir's strength in modern application, community and open source activity. We are a part of that today, right? This talk is part of community. And a little bit of code syntax and features. This may not be relevant to the house present today, but assuming I get feedback from you and some other workshops we do, there may be many people who are not necessarily informed as you all are, right? So please keep that lens in mind, that some information is very basic. You may be far more experienced, but I'm trying to cover all quarters and play to the house, right? And then I have some ideas that I feel are worth discussing for real world application, because the saying is talking the talk is one thing, but walking the walk is another, right? And then we can have a quick Q&A. All right. So the history of Erlang is that it essentially was started at Ericsson, and the problem fundamentally was very simple, that telephone switches were the only scalable piece of technology back in the day. This is before the internet. So imagine thousands of phone connections coming into a telephone switch and many being connected, incoming, outgoing. And this was the only scalable piece of technology. And the idea that a lot of research I did online, something I came across was a bit of capitalism played a part as a catalyst in creating Erlang, which is something that I didn't find in many blogs, right? That as the telecom sector went and became a private sector, right? The telecom deregulation happened. This created competition in the market. That means a software upgrade was needed to scale these telephone switches faster, better, to make them more fault tolerant. And as deregulation of an industry happens, since more competitors come into the market, automatically the R&D goes up. And Erlang was an output of one of these R&D projects at Ericsson. It was not a sure shot target, which can be a lesson for all of us, right? That sometimes there is an instinct that this needs to be solved in the world. There isn't a clear path to it. And just like that, I feel Joe Armstrong, Robert and Mike were not exactly out there creating a new language. They just had a problem statement. And the problem statement led to the creation of this beautiful piece of machinery or a system, as you can call it, called Erlang. So the early history is that the name comes from Agner Krupp Erlang, who was a Danish mathematician. OTP here stands for for those who don't know, the Open Telecom Platform, which was open sourced in about 98. The language design choices are very particular because as you can see, that concurrent, functional, garbage collection at runtime, and ideally designed for very high level of concurrency and fault tolerance. Right? You can continue to read these bullets, but there are some interesting facts that I want to share with you. That Erlang didn't come out as the first attempt. What Ericsson actually did was take a lot of programming languages that were already prevalent in the world, and they tried to solve the problem with the tools that they already had, just like we all do, right? We go to the framework or the language that we are well versed with. We try to solve the problem at hand. Somewhere we come across those bumps, hurdles and walls which the language and the framework that you are so in love with has just not factored. And that led to this team identifying different pieces of different technology that was good for them, but no one piece of technology where everything would come together. And that is why after many iterations on existing programming languages, they decided to do Erlang. That hey, nothing's working, let's take the best features from different places and start creating this declarative programming language, which we are discussing here today. From Erlang came the birth of Elixir because of Jose Valim in about 2011. 2012 is the official start as per the gentleman himself in an interview, but the facts read 2011. However, I think he formalized the community and other things in 2012. So the motivation was that Erlang is very powerful but written in 1980s, and why not bring this power of fault tolerance and concurrency to other developers like us in the world. The key features of it, as we've already discussed, are concurrency, scalability, the fact that it runs on the Erlang VM, which means Elixir also still under the hood is running on this thing called Beam, right? And Beam as a VM is extremely optimized for the purposes that Elixir serves today. That is, the fault tolerance and the concurrency are kind of built in to the virtual machine on which this is being run and interpreted, right? In which the bytecode is being interpreted. It also remains interoperable with Erlang. Hot fixes, something they built into the language. Imagine for people 30 years ago to be thinking that we want a telephone switch that has to continuously run. Some calls can drop, but the whole system together must never drop. And at the same time, we know that we would be continuously doing upgrades to the firmware, to the software, but make sure that the entire switch system is not collapsing. One more fact that Beam, you will come across the word often in this domain, but it stands for Bogdan or Born Erlang Abstract Machine. That's the full form of Beam. And funnily, it was not the first VM. There was something called Jam in the ecosystem. So the entire language was actually first running on a virtual machine called Jam. And then this gentleman who was working in R&D inside this team came up with a highly optimized virtual machine, and that's why they switched from Jam to Beam. So Beam is actually the second VM. The first one was Jam. Yeah, that's a fun fact that I came across. And Jam stood for Joe's Abstract Machine. So both were named after the research scientists who were working on them. And like I said earlier, that in about 1998, as Erlang was made open source, it still took about 12 to 14 years, right, to arrive all the way at 2011 for somebody to spot the potential of this technology and to kind of make it more accessible for guys like us. Some recognized organizations benefiting from it, obviously WhatsApp runs on Erlang and Discord runs for millions of messages on Erlang, and then you have Pinterest for their notification system using Elixir and the Erlang VM. So clearly some of the big names in the industry are using it, and the potential is there for this technology to become more prevalent to the masses. Some respected contributors, like I said, I don't think founder is the right word, but the inception or the creator for Elixir is Jose Valim. Then is Chris McCord and Frank Hunleth and Justin Schneck. And some of the top companies in the world, although Erlang Solutions is written last, it happens to be one of the most prominent names in terms of enterprise solutioning today for Erlang and Elixir based solutions in the world. Right? This slide we will take some time because ultimately we are here for Elixir meetup and we would like to discuss the strength of Elixir. I'll leave you to read the bullets, they are quite obvious, many of you will be aware of it already. But I'll take you through some other fun facts that Elixir today is a perfect language for you to build something for a scalable server that has to deliver things globally versus something you want to put on a Raspberry Pi and create an IoT device with real-time inference, concurrency and fault tolerance. In one of the interviews, a gentleman informed that initial setup with one server of Elixir was able to handle about 30,000 connections. They changed 10 lines of code. And can anybody guess how many connections one server was able to handle with 10 lines of code changed? And we are talking 2016-17.
20 million?
2 million.
Oh.
Yeah. So again, fair enough. But from 30,000 to 2 million with 10 lines of code changed shows the underlying potential of this language. The things I would like to highlight about its strength first is the process model, where it uses a very lightweight process model, which means it has its own isolated memory and heap for every single process. It has concurrency because it works on an actor model. Essentially, no memory is being shared between processes, they are sending messages to each other. Fault tolerance, which from the creators all the way to the very well-versed developers, they really harp on this fact that it's fault tolerant as a language and as a system. And what makes it fault tolerant is this supervisor tree that is built into the language. So you essentially have a process supervisor. When you launch that spawn and you spawn a new PID, there is a master supervisor that may be supervising a process and a few other supervisors. And then this tree continues down, monitoring certain processes and monitoring certain other supervisors. And as one of the process fails, the fail fast philosophy of Erlang and Elixir kind of kicks in, because it says that, hey, if something is failing, just let it fail and restart the entire system again. If it is failing because of a dependency on another process, then maybe it has the intelligence, the supervisor has the intelligence of saying, hey, let's kill that process first, restart that one, and then restart the one that we are facing an issue with right now. Hot code swapping, we have already discussed, the ability to fix or include features on the fly without stopping the entire system. Garbage collection, again very important, because each process is essentially collecting its own garbage and managing it independently. So this ensures that there is no system-wide garbage collection. And imagine this happening over 1 million processes, there would be a pause in the system. But because each process is doing it for itself, the system is able to continuously run. So there is never a block. No blockers at all is one of the key strengths, according to me, of Elixir. And I'm not an expert, I'll be honest, but I'm fascinated by it and I hope to be an expert in the coming few months or years, whatever time it takes, right? Learning is endless.
Actually, I forgot your name. Akshay's talk was about GC in Elixir. So
oh, wow.
Yeah, you should come. Like,
I'm gonna.
The same thing you're mentioning, we just dived deep into that actually.
Very interesting. That must have been something very informative. I will be exchanging slides with all of you on this group, so I'm sure I'll come across that. Cheers. A few other things I would like to dive into here is something that the VM does at the virtual machine level, which is TCO, and that is the tail call optimization. And I think that is something very critical to this language in itself, because it is not built in the language, it is built right at the VM level, right? And that is creating this ability for modern systems to be extremely efficient and fault tolerant. And instead of repeating these words, we live in a world where web applications today are being used by millions and billions of users, right? So I think the word fault tolerance, concurrency, fail-safe and reliability in no way hold on to the telecom world. They very much have meaning in your and my lives today, even if there are personal projects we are working on. And lastly, the community and ecosystem. I'm very happy to be here amongst friends and people in person, right? We've all forgotten COVID was just a few years back. This word in person was missing in our lives. But it's nice to be able to be in a community and share these thoughts, have these dialogues and interactions. And I think Elixir has a very popular community base in general across the globe. Elixir Delhi may be I won't say it's new, but it's still in its nascent stages. And I think we have a long way to go as a community together. Not just talking, but also building things, sharing things, and inviting others to come become a part of this. That should be something we all hold close to our mission. Let's quickly jump into the code, right? Because ultimately it's a programming language and there are few syntaxes that are different, but I do feel that for a self-taught developer like me who's learned to code on his own, I found the syntax and the overall flow quite easy, which means there is an underlying thought to it. And for those of you who are obviously much better at all this than I am, if I found it reasonably easy, you would always obviously find it a breeze, right? So this is a simple instruction that is equal to console.log or print of Python, and it essentially prints hello world to the console. We have variables and pattern matching, as you can see here. That's something that we would do. This would be equivalent to the fstring method of Python, and that is how we are able to do variables. And we will dive into other examples of pattern matching more in detail in the next 1 or 2 slides. The language itself fundamentally has a structure of immutable data types. So as you can see here that there is a list 1 and a list 2. And then we have the consing operator. The pipe essentially is consing. And I kind of went into the research of where this came from, and it came from the language Lisp, which had a great dominance for list handling, management, merging. And that's where it came from. And this word consing also has continued in the SDLC across industries, starting from Lisp. So as you can read clearly that it appends 4 to the head of this particular list, but it doesn't necessarily change that list. It essentially creates a new copy of it. And that's pretty much what we mean by immutable data. Elixir has a very deep, well thought out system for pattern matching, which we all primarily do when writing code or managing data of different kinds, massive arrays, right? And as you can see in the example here that A prints out the pattern matching A, B, C, and it assigns A to 1, B to 2, C to 3. In the second example, I think a few interesting things are happening. One is the operator tail. Head and tail are being highlighted, which I found very cool. I am not a very well-versed programmer. Like I said, I've learned this over the past few years. I don't come from the computer science background. So if you all are aware of head or tail syntax in other languages, please enlighten me. I came across it first time, right? Because I've been dealing with Python and then I've been selecting the index key for it, and I was like, oh, this is pretty cool. I just type head and tail and it knows what to do. The underscore essentially tells Erlang, if you want to avoid those messages in your terminal, right, or in your IDE, saying that, hey, you've used this variable, but unused variable prompts. So this is our way of kind of telling Elixir that, hey, look, I want you to do this, but I'm not going to be using it ahead, and don't raise an alarm for it. That's what the underscore does. And A essentially assigns to 1, B assigns to 2. And any guesses what the tail would assign to? Would it be just 4?
3 and 4.
3 and 4, perfect. So let's move on to the next one. There are no traditional loops, as you know, in this language, right? So you start typing a for and while loop, and then you are certainly in very new waters. But what I realized is that the absence of it helps you think very recursively and very naturally. So you're kind of thinking of systems, and at least I am, having been on Python, I am suddenly thinking of systems in a very different way. Because the first time I read it, I was like, wait, I think they goofed up. This is a bug. How could they have missed out on for and while? But obviously these are better minds than mine, and they have thought it through, and you can pretty much achieve everything that you achieve with for and while loops using a different method of conditionals, which we will come ahead. Again, if and else are not present, if and unless are, and one prints, one does not. Let's go to the next one. You have the ability to define your own modules and functions within them and very easily call them out. So greet Alice is essentially calling that greet function there, which is existing within the module greeter. and you could have multiple functions within that one module that you can then use throughout your system. We were talking about recursion a while back, so let me ask you a question here. What would happen if we called the result math.factorial with -1?
It will like give a match error.
It will give a match error.
And what would happen to the process?
It will crash.
The
Correct.
process will crash, yeah.
But the beauty of Elixir is that whole crash is kind of anticipated. It would not crash like other systems crash with a lot of noise. It would simply go to the first base assignment and say, hey, doesn't fit. Go to the next one and say this doesn't fit, and the whole process would completely shut down. What would happen if we then reassign math factorial, say in a more complex system with a positive integer? Would that process be able to respawn itself and execute?
Yep. I think so.
That is precisely the fundamental basis of what Elixir does. That it would crash in a certain scenario, and that crash is all right. We are not writing defensive programming saying if -1 don't do this or do this. So you notice it is actually writing code with a sense of optimism that let's write for what will work, and we'll see what happens to when it doesn't work. And I kind of personally like this notion of optimistic progressive programming, which Elixir brings to the table, right? Very quickly, in the previous example, you will notice that the VM has this ability to call on the same stack when it's running, so to speak, a loop, right? But in this example, there is no accumulator that has been added. So are you truly leveraging the tail call optimization in this piece of code? You're not. Exactly the same piece of code with only one line addition and a call to the function itself in the very first line is how you are enabling TCO. So now essentially what you are saying, and I'll show you in the last slide how it runs in the backend, how the VM actually runs these calculations at the backend. In the tail call optimized version, the result is saved in each iteration. Whereas without it, in the previous example, as you saw, all of them are stored in memory and then recursively added together to create the factorial for the number that we are calling at. So behind the scenes, with tail call optimization, it would run with factorial 5 and it would assign the accumulator 1. And then you're all quite well versed with this. As it would go down, it would call 4 and 5 and assign the accumulator, which is 20. Then the accumulator assigned would be 60, and then 2 and 1. And as it reaches 0, which is the base condition, it would stop and say, hey, now I'm going to return just the accumulated value, which is 120, which is the right answer. Whereas in a non-optimized call, which was the first one we saw, it would call factorial 5, which in return would call 5 into factorial 4, and so on and so forth. And essentially each result would be stored in memory all the way till the end, and then the compiled memory, all the results stored in the memory would be presented to you as an aggregated result. Now, it's obvious that if that n was a very massive number, this wouldn't work. But that would never have a stack overflow issue because of tail call optimization that I've built in. And I know I've used this a few times, but I was quite fascinated by it, so I dove a little deeper into it. Atoms happen to be a very critical part of this language. I'm sure you're all well aware. And I'll quickly run you through this, that essentially the error is an atom, right? With that sign that you see. And OK is also an atom. And in the usage below, you can clearly see that the status and result are being assigned based on the function that you have defined on top. What is an atom? An atom is something whose name is its own value. This is how the Elixir school and the Elixir documentation presents it. And I think it's very well written. Its name is its own value. An atom can also be used as keys in different maps, right? So you can see here that if you were to use name and assign this as an atom, which is equal to the name that you've assigned on top, it still works. You can use atoms in pattern matching again. So you can see here that the error message would be relayed if you sent it with an OK message or if you sent it with an error message, right? So it's connecting to the correct atom. Atoms can also be module names. So over here, if you run IO puts is atom my module, which we've defined on top, it would print true. And this is also interesting that you can actually call out to a module in both ways. Both are absolutely correct. Concurrency is something that is built in and Elixir takes great pride in it, right? And it's something that we can leverage in modern applications. Now, when you use the inbuilt command spawn to spawn a new process, something that I think we discussed outside also is that each process is a few KB. And that's kind of fascinating. Just a few KB for a new process means I'm capable of running millions of processes on one decently powerful machine, which are all capable of handling whatever task that they are assigned. This, in real world application, means we can design systems that have real-time availability for million users. But the minute we talk about million users, this concept of cost comes to mind, right? Infrastructure has a cost. But in languages like this and frameworks like Phoenix, if you were to build web applications, we are actually capable of serving a million users at 1/4 the cost of what other languages are offering today. Which means for guys like us who are one-man army or who may team up to bootstrap an idea to the market, this is a great solution practically because it keeps our costs under check and at the same time gives us scalability that, hey, if my idea clicks and it suddenly finds traction, I'm not going to have to rewrite the entire code. It will work as it is and offers me scalability. Community we've already discussed. There is Elixir Delhi. I put that bullet last, but then I put it first because I thought we should start with it. And forum, Erlang, HexPM, status, GitHub, where the open source language is being maintained itself, and Elixir School is where I am going to school right now, right? Nearing my mid-30s, but since I learned to code late, I think I'll be studying for a long time. But Elixir School is a great platform, giving you very concise lessons and information, makes learning fun for anyone who's listening in or watching this later. Also, highly recommend Elixir School as your starting point. Now guys, let's have a friendly discussion about the application. That there are a few of us in this room right now, right? And what could we do with Elixir starting tomorrow if we wanted to? And if any one of you finds interest in any of these ideas, like I said, I'm an entrepreneur, and for an MVP state or to experiment or to learn together or collaborate together, I'm always interested. So please reach out to me at the end of this talk should any of these ideas line with you. They seem voluminous. I'll share the slides later, but right now I'll just take you through the headings that the kind of technology we can build today using Elixir is real-time messaging apps. And yes, WhatsApp exists, Telegram exists, but think of other contexts, right? You want an extremely reliable fault-tolerant system in places like Israel and Palestine where conflict is going on. You want an extremely reliable fault-tolerant system during natural disasters. You want an extremely reliable fault-tolerant system in the medical healthcare industry where people are dealing with, say, organ transplant, where messages and time is very critical, way more critical than what other systems have ever factored them to be. Because I don't receive a birthday message or a good morning message in a WhatsApp group, it's okay. But somebody doesn't receive an organ matching message, that has serious implications, right? Live dashboard and analytics. I was sitting and I was like, horse racing. Imagine a world where horse racing is being done using apps and people in an entire stadium witnessing the race are able to place their bets in real time. But the underlying system has to guarantee that things are in as near real time as possible and are fault tolerant because you're dealing with people's money. I know it sounds like gambling, but it is a legal sport in India. And for some of us here who may want to, make our bread and butter in life, there is a famous saying by Shah Rukh Khan, don't become a philosopher before you become rich. So if you ever want to design a system that can make money in the market, I think Elixir has many applications in the gamification industry, healthcare industry, real estate industry, and others. Real-time inventory management could work for any large warehouse. Live sport updates, again, a very popular notion. Online auction platforms would be great because you'll be able to instantly sell things and guarantee that the first click, first buyer gets the bid that they put in. Financial trading, remote education, customer support with live chat, real-time event broadcasting, public transport, and health monitoring systems. It just goes on to show you the diversity and scalability of real-world ideas. And I can assure you that I'll be working on at least 2 or 3 of these, probably in the next 365 days. That's a target I have set for myself. That I would like to take to production. I don't know whether it will fly, but at least from my end, I would like to put in the time and effort and take something to production, and we'll see where it goes from there. With this, I'll be coming to the second last slide. In case you guys want to scan, last one's hidden, Elixir Delhi community behind me. But that's the Elixir School QR, and that's an interesting video of Jose William that I saw on YouTube. And the man it's a 14-minute video, and he's speaking very honestly about what, why, and I found it very nice to hear it from the creator's mouth, right? Hear from the horse's mouth where things are going. And with that, guys, I'd like to end. I hope that we can create some value and meaning in this world together. Thank you.